Hi everyone, my name is Yiliu, a third-year PhD student at the University of Illinois Urbana-Champaign. Today, I'm presenting our work on exploring research question co-creation with a large language model-based agent about a system we designed named CoQuest. So let's get started. Identifying research question is a critical step of scientific research and discovery. To formulate creative and valuable research ideas, researchers often start with searching and scoping the relevant literature, especially when the research involves working spanning multiple domains. Developing novel research questions often requires extensive literature reviews, especially in interdisciplinary areas. Reading a large body of literature, synthesizing them, and identifying the relevant work can be rather time-consuming. Developing research question is also iterative, that researchers would also need to have an initial idea or topic in mind, and then conduct a literature search to refine the idea and repeat this process until they have a satisfying research idea. To this end, we introduced the system CoQuest for human-AI co-creation of HCI research questions. The CoQuest system is an interactive web application that allows agent large language model backend to allow users to interactively create and refine research questions that are grounded in relevant literature. First, let's talk about how we designed the CoQuest system. To understand how researchers create RQs, we conducted a formative study with actual HCI researchers. We first conducted semi-structured interviews with 4 HCI researchers about how they formulate research questions in real life. We then organized a focus group with the same group of interviewed participants to identify their needs for an RQ co-creation system. The focus group study is guided by 3 major questions. First, what questions will you ask the AI system? What information do you want to provide for the model to generate RQ for you? How do you produce research questions currently? We synthesized the results and findings from the formative study and proposed a novel conceptual mental model aiming to capture the major interactions during the process of human-AI co-creation for research questions. The proposed mental model consists of 3 major components: understand literature, present RQs, and explain AI thoughts, and refine and rescope. The process of literature discovery often involves reading and summarizing a wide range of existing works. AI can be best used to perform factual summarization and distillation of findings and knowledge before presenting them to humans. On the contrary, proposing and refining research questions often requires more creative thinking and generalization beyond past knowledge. In this scenario, it is crucial to involve both humans and AI through the design of mixed initiative co-creation systems in order to combine humans' expertise and preferences with AI's domain knowledge. Based on the mental model, we further distilled the findings from the formative study into 3 design requirements for the system. The design requirements include: first, the system should be able to assist users' brainstorming processes by automatically generating research question candidates through incorporating human feedback. The system should also be able to support user sense-making of AI's outputs by explaining the rationale behind each generation. Last but not least, the system should also be able to help users discover relevant literatures and identify research gaps. The 3 design requirements we discovered through a formative study guided our design of the 3 major features of the CoQuest system. The first design requirement, that the system should support users brainstorming with human feedback, leads to our design of the research question flow editor feature. The CoQuest system offers an interactive research question flow editor panel that allows users to co-create RQs with AI in an iterative manner. This panel is designed in a way to resemble the design of a mind map, where each RQ node represents a generated research question. This allows users to organize research questions more easily on the different topics while preserving the hierarchical structure among different RQs. Users can type in their rough ideas or keywords by creating an initial node. When users click on one of the nodes, the node expands, and the user can first type in textual user feedback to AI in the text box, and then right-click on the node to generate more follow-up research questions. We then introduced the second feature of the system, the AI Thoughts panel. This feature is inspired by the second design requirement of supporting user sense-making by providing rationale and explanation for AI's outputs. Between each pair of RQ node, The AI thoughts feature represents the relation of which research question the newly generated RQ is based on. They also contain information about the results of the action undertaken by the agent leading up to the newly generated research question. When the user clicks on an age, the AI thoughts panel appears that displays the results of the agent's action in a narrative format. The CoQuest system uses an agent large language model framework to generate creative research questions, following the React framework, by adapting the Think, Act, Observe framework when designing the prompting method. The AI thoughts are generated following the React framework, and we use 3 predefined actions to help the agent generate research questions with better quality. The actions include search and summarize related works, hypothesizing use cases, scoping and narrowing down, and reflection through comparison with existing works. The third feature of the system, Paper Graph Visualizer, corresponds to the design requirements of providing support for literature discovery, as the proposition and the refinement of different research questions needs strong literature grounding. The Paper Graph Visualizer is designed to assist users in efficiently identifying and exploring existing works related to each generated research question. When a user clicks on one of the generated RQ nodes, the Paper Graph Visualizer panel reveals itself by visualizing the top most relevant papers along with their citation relations retrieved from our citation graph. The top similar papers are retrieved using maximum marginal relevance with the sentence embedding of a user query and each paper's title, metadata, and abstract text. The paper nodes in the citation graph are also designed to be interactive. When the user clicks on one of the paper nodes, the detailed information of the selected paper will be displayed below. Now, with the CoQuest system, we conducted a user study to answer 3 research questions about how users use the CoQuest system for RQ co-creation and their perceptions. More specifically, we asked the following 3 research questions. How do users perceive the co-creation experience and outcomes when using the CoQuest system? How do users interact with AI when it provides different levels of initiatives during the co-creation process? And what different behavioral factors associated with users' enhanced perceived experience and outcomes in human-AI co-creation when using the CoQuest system? To better answer the proposed research questions, we introduced 2 design options regarding how the system generates follow-up RQs. The 2 conditions include breadth first generation and depth first generation. Under the breadth first condition, several RQs are produced simultaneously in parallel, while under the depth first condition, follow-up RQs are created one after the other, with each new question building upon the previous one in a sequential manner. These 2 conditions are designed to represent 2 levels of AI initiative during co-creation. We conducted a within-subject user study with 20 participants. Each experienced both of the 2 designed conditions. The findings revealed that participants perceive the breadth-first approach as more creative and trustworthy upon task completion. Participants have also pointed out that the breadth-first condition results are easier to interpret and require less wait time to obtain the same amount of RQs compared with the depth-first condition. The participants also found that the breadth-first condition gave them more control over which direction of RQs they would like to proceed with. Interestingly, in contrast, during the task, participants considered the depth-first generated RQ as more creative. Participants has also pointed out that depth-first condition helped them discover surprising RQs as well as refine and dive deeper into a chosen direction of their own. Additionally, we discovered that AI processing delays also allowed users to reflect on multiple RQs simultaneously, leading to a higher quantity of generated RQ and an enhanced sense of control. Now we have analyzed both users' co-creation perception and outcomes using the CoQuest system. We further examined the associations between users' behavioral background and their co-creation experience. We identified a positive association between all 4 dimensions of user-perceived RQ ratings and the average length of users' input feedback to AI. In addition, we found that participants with a higher utilization of our generation wait time also perceived stronger control towards using the system. In contrast, participants that are more familiar with the topic they are exploring, in turn, perceived weaker control when using the system. Based on our study findings, will provide insights on additional factors to consider when designing future human-AI co-creation systems for research question generation. In our study, we discovered that leveraging the wait time in AI-based co-creation systems like CoQuest can potentially enhance users' creativity and control. This challenges the common belief that delays in AI systems negatively impact user experience. Additionally, we found that balancing the degree of initiative taken by AI with user agency is crucial. A balanced approach leads to a more engaging co-creation experience and innovation outcomes. Lastly, personalizing co-creation systems based on the individual researcher's background, stage, and preferences can lead to more relevant and effective research question generation. Thank you for listening. To learn more about the project, you could search CoQuest on GitHub to find the source code of the system. And please feel free to contact us if you have any question.